Yeah, I'm very often I'm reviewer number 2, and so I would like to tell you a little bit about open science from the perspective of a reviewer instead of someone who's trying to publish. Now the story starts in the October of 2020, and the COVID lockdown was in full effect. But I was happy because I just achieved my dream. At that time, I was awarded a full-time permanent position at my university. I had made it. I was not a researcher, I was a research software engineer, which was a new title they introduced. Instead of trying to publish or perish myself, I got to focus on one of the things I love most, which is writing code, helping others write code. I was off the hamster wheel. I did not have to just run as fast as I could anymore just to stay where I wanted to be, just to stay in science. I had a permanent position. Life was good. Of course, I tweeted about this, but for some reason, not every editor of every journal read my tweet, so I still got requests for review. And so a random journal will come review this paper. I was like, no. I don't do that anymore. I'm off the hamster wheel. Don't have to work for you for free anymore, especially no longer for a publisher whose business model revolves around exploiting the free labor of academics. No, that felt good. But then a review request came in, and this one I could not refuse. I knew this editor. I consider him a friend of mine. Because this was the man who is responsible for my career in open science. He is the leader of a large open source software package that is used throughout the world for MAG data analysts like I was to get our job done. And when I started contributing to this open source project, I got in contact with him and a world opened up for me. Many contacts. At conferences, people would come up to me and say, hey, you're a developer on that software package. I use that every day. That's amazing. Even more, this is the guy that I put down as a reference when applying for the RSE job. So 1 month ago, he was actually approached by the hiring committee and they asked him about me. And he said, well, he said some very nice things, he told me. In other words, this is a man, I could not refuse him this favor. So yeah, when he has, of course, okay, I will review. I'm no longer a researcher, I'm a software engineer. So here I am stuck reviewing a paper. But I come across this. All data and scripts used in analysis are available upon request sent to blah, blah, blah. We've all read this. How many of you actually tried to ask for the data in the code? Have any of you tried? Raise hands. Yeah, a few. Did you get any responses? I see a lot of this. Mixed feelings. Yeah or no? Well, I gave it a go. To my pleasant surprise, they sent me the code. Wonderful. Not only did they send me the code, it was actually quite good. I could read this, I could run this. And so I started doing it. I started opening the code and going through the files. And you know what happens when you go through somebody else's code? You can actually see the work. So you can maybe see there are a couple of commented outlines there. Those are the things that failed. I can see all the little hacks that were needed to get this to work. You know, you get a view inside the kitchen. You know what that does to me as a reviewer? That puts me on your side. Reading through your code, seeing your struggles, I want you to succeed. I move from being just an adversary, like what is this paper, to being something that someone who sympathizes with you and I want you to succeed. And that made me also much more happy as a researcher. So for this little lecture, I want to paint for you a roadmap based on my experiences as a reviewer. How can you share your code and data such that I can run it and I will be on your side? And that starts with this. It starts with just responding to my request in the first place. So often people don't respond to this request. People don't share their code, even while they wrote down they would. They still don't. But when a reviewer asks, they will. And I encourage you to actually do it. So do share. So it does start with when you go through, share your code and share some data to run this code on. Just do it. It does start with, you have to go through it first and remove sensitive information, like names of participants and things like that. And you have to anonymize your data. So that's you can't skip that step. That's something you absolutely have to do. But after that step, just put it out somewhere. I don't care if you just put your code on Google Drive somewhere. Just send me a link. Of course, if you want to be more fancy about it, you can put it on OSF, the Open Science Foundation website. That's so specialized in sharing sciencey data in code. If you just want to put it on Dropbox, that's totally fine with me. I can work with that. Now, don't put your data, though. Don't put neuro data on Dropbox or Google Drive. Don't do that. Do put it on something like OSF or your local repository. That's how the roadmap starts. That's basically all it takes. It doesn't take that much effort. The reviewers, the authors of this paper I was reviewing, they didn't put it on Google Drive, their code. They actually put it on GitHub. And I love that. So if you don't know, GitHub is like the largest open source platform. It's a large collaborative platform. If you put your code on there, that allows me to do this. I was reading their paper, I was reading their code, found a bug in their code. Well, I'm reviewer number 2, gotta be an asshole about it. I don't make the rules, I need to point it out. But this is on GitHub, so I didn't have to point it out like in my official response to the authors and they would reply in their rebuttal letter. I can just ping them on GitHub and say, oh, by the way, I think this line, that should actually be that. Gotcha. Hour later, this was their response. Marijn, hi. Oh yeah, there's no anonymity on GitHub. They know exactly who I am. You're right, man. Thanks a lot. And this book, hopefully, it should not affect the performance critically. It did not, I checked. But we will check that within the next several days. And they did, and they fixed the bug. But when I read this message, I think they seem generally happy about this. This is, I think, for me, way better than the, well, we appreciate your comments and an interview, that shit that you get in the rebuttal letters. I was feeling very happy about this. If I can review like this, I enjoy my job much more. I actually might enjoy reviewing now. Let's put that into our roadmap. So you can share your code anywhere, but if you want to be a bit more fancy about it, go ahead and share it on GitHub. So I can just raise issues and I can make little notes and we can have little interactions on GitHub. I love that. So I will be adding to this roadmap throughout the talk. Whenever we have options like these 3, I tend to put the most basic option to the left, and then we get more fancy as we go to the right. So you can sort of decide how fancy I want to be. Because if you want to use GitHub, it's a bit more complex than just putting in a Google Drive, because you need to use Git. It's a complicated tool. It's a bit more investment. It's worth it in my opinion. And if you don't want to bother with that, just put it on Google Drive. It's fine. Next. So I started asking for this all the time now. I got another review request and said, well, to them, well, I don't see any code or data there, but if the authors are willing to share their code and some data to run it on, okay, I will be willing to review. And the editor said, okay, well, I will go ahead and ask the authors then. And again, the authors complied. And they sent me their code and their data. They put it all on OSF, in this case, which is absolutely fine. Little folder with data and code. But you know what these authors did? That made my day. They wrote a README file. They wrote a little file there. It goes like, to recreate the figures in the manuscript, follow these steps. I can do that. You first need to obtain these software packages in order to run this code. Those are their dependencies and a little list of packages. Fine, I'll just put them in there. Download all the stuff from OSF. And then in MATLAB, go to MATLAB, navigate to the code directory, and run one of the plotting functions. And they had for each figure in the manuscript, it just had a single MATLAB function I could run that would generate that figure. That was beautiful. I was up and running in 10 minutes with a few instructions like this. It doesn't take much. Let's put that in a roadmap too. That was brilliant. So if you can, like add an example there. Just add one script that you can sort of point to, run this thing to like make stuff happen. That helps me so much. Write a little README that just lists like, okay, these are the packages that need to be installed for this to run. This is where you can find the data, and this is the example script that you can run to make stuff happen. If you add something like this, I will be up and running your code in no time. And that makes me happy. That puts me on your side. You want your reviewer to be happy. Of course, I was doing this. I was reading their paper and also scrolling through their code at the same time. I'm deeply enjoying I get to do this now. And then, of course, when you review, always questions come up. And normally you would put these questions back into your review response and sort of. I wonder if the authors had thought of doing this and this and this, knowing full well that the authors had not thought about this. It's basically more it's your question that you're now asking the authors to do in a hoop for them to jump through in order to get their stuff published. And well, I sort of had to. I mean, but now I had the code and I had the data and I had it all loaded up already. It would took me less than 5 minutes to just try that myself. And I got to write in my review report, I got to write something I never written before. I wrote, well, the humanness dimension still performs well. When the analysis is restricted, that was my question, to only non-living objects, I checked. I was able, because they shared their data and their code, I could quickly jump in. I could just check this. I did not have to go through the authors and, well, please do this analysis for me. I could just quickly check it myself. And I was very happy to see, yeah, actually your result still holds up in my little edge case. I was feeling very good, like writing a review report like that to be supportive. So it feels, when you share the code, and I as a reviewer, I can see your data and I can see your code, and I'm in the kitchen, so to speak. I feel much more like that we have a more collaborative relationship now together than an adversarial one. This is like generally a much better way also for a reviewer to approach this. I can actually be way more helpful if I just have access to these things. Another big contributing factor to that was that I was able to do this so quickly. I was sort of reflecting on that. Like, why was I able to do this so quickly? And one of the things they did very well is their code was small. And this was also in the case for the first paper. It's actually wondrous. They went through their code and they removed all, well, your code folder, my code folder, always is like a giant mess. So when you share the code, you go through it and you only keep the stuff that actually ended up in your paper, like all the failed experiments, all the side tracks, you just pluck out of there. What actually remains is a quite small amount of code, the code that actually mattered, the code that actually ran. And if it's just a small amount of code, it is so much easier for me to work with that. I can view that if there's like things I need to tweak with, it's no problem. As long as it's small, it's no problem. So let's put that to the roadmap as well. Just select only the relevant part, clean it up a little bit, just make it small. Small is good. And they actually also did that with the data. So I was able to answer my question, try a few things very quickly. They did, because they supplied me with the pre-processed data. They supplied me with a version of the data, processed up to the point where their analysis, their research question became relevant. So not the entire pre-processing part. I did not have to do the entire pre-processing pipeline. I could jump right in where it mattered. And that made me a lot more efficient. So I'm going to put that in as well. Please do that. That is very helpful. But of course, you're now going to say, yeah, okay, but this is open science. We should share the raw data. So if you, and if you're going to share the raw data, then one of the tips from me to you is to use the bits format, which is a standardized format for sharing raw data. So let's add that in as well. If you want raw data, of course, anonymize it first. Please convert it to bits, because then it's in its standard format. You can upload it then to OpenNeuro, which is a great website, and they require your data to be in the bits format because then they have all their data sets in the same format. You can run metadata analysis on it. It's beautiful. So please do that. But then take into account, so the next paper I reviewed, they actually did this. So the next paper I was reviewing, yeah, they wanted to share their raw data. They converted it to bits, like you should. Of course, this conversion, this involves like renaming all of your files and your folders, and your data is now in a different format. What they did not do is update their code to reflect this reality. All their code still operated on the original version of the data, which they did not share. They shared the bits version as they should, but none of their code worked. And that pissed me off a little bit. If you ask for the code and none of it works, that does not put me in a happy place. That put me in a sad place. So, you know, I'm going to add to the roadmap. So make an example. Just run your example at least once on your local machine to make sure it, at least on your machine, it just runs with the data you're actually sharing before sending it to me, please. And that's it. That's it. That's basically all you have to do. If you do that, I will be able, as a reviewer, I will be able to open up your code. I will be able to open up your data to see what you actually have been doing and sort of be on your side, be much more productive with you. Now, there are a lot of people on the internet that disagree with this, I assume. They say this is not enough. You are not doing open science if your code is not completely documented head to toe. You're not doing open science properly if I have to change a single line of your code in order to get it run on my machine. Please ignore these people. This is not necessary. And I think this is actually hurting the adoption of open science quite a bit, this gatekeeping. There's a lot of gatekeeping for open science. People who maybe mean well, but they demand so much of your code. They demand that. I've even seen people on Twitter like say, your code really should have unit tests. Really? Are we going to put the bar that high? I don't need unit tests. Even if you don't know what they are, that's fine. Be blissfully ignorant. I don't need that as a reviewer to just look at your code and run it and just be on your side. This is what it takes. But why is this? Why is this enough? Well, if you look at what we're actually been doing now in this roadmap, when I say select only the relevant bits of your data, what we're actually doing is we're organizing your code base. So if you enjoy doing this, this is a rabbit hole you can go down very, very deep. But it starts with just cleaning out like the unused parts. That's where it starts as the most important part. But then, of course, there are a lot of other things you could be doing. When I say you remove your sensitive information from your code, what we're doing is we are enforcing like a privacy policy on that. So there's also a big rabbit hole to go down there. Like how do we ensure like anonymity of our participants? How do we like take security into account, things like that. When I say write an example script and write a little README file, what you're doing is you're documenting your code. You're documenting your code in a way that actually matters. But of course, documenting your code is also a big rabbit hole you can go down in. When I say run your example, what we're doing is we're doing tests. They're not maybe unit tests, but you are testing your code in a way that's meaningful. And when I say you can put it on GitHub, for example, what we're thinking about is how to distribute your code. All these things are very deep rabbit holes that you can go down in. You can do so many, you can all do is more fancy. You can always do it better. And don't listen to the people who keep screaming like you have to do every single one of those. It's okay. I would say if you just do the top part, it's enough. Anything else that you do, of course, hey, I'm not going to stop you. It's just going to make my life even easier, and it's not even going to make it even better. It's not necessary. The top part is there. Let's see, how are we in time? A few minutes left. Maybe I should share this one more story about we're now up to 4 papers. Okay, 4th paper I reviewed. And again, I asked for the code. Again, the author supplied me with the code, and I was reading through it. There's things, and this paper was about a method, an improvement they made to a method. They invented a new correction term for an existing thing. And they claimed in the paper, with this new correction term, your results will be better. But the correction term came with a parameter you could tune. How much correction to apply? Of course, then the question is, okay, what should you set this parameter to? And their answer in their paper to it was, well, we're going to fit it to the data. We're going to let the machine learning algorithm tune the parameter. That's a fancy way of saying you write a for loop, you just try every combination, and you pick the best one. So that's what they did. That's fine. But then, as a reviewer, I asked, okay, I'm now curious. So what was actually the correct value for that parameter? What did your algorithm choose? And they did not mention this in the manuscript at all. And well, normally I would just write that in my review report and we do a whole refill cycle. But hey, I have your data loaded up, I've got your code loaded up, and then it takes me 5 minutes to check, right? So I checked. For every single item in their data set, the parameter was set to 0. Apply no correction at all. Okay, that's curious. If you have a new correction method but you don't actually use it, how is your result better? So I started digging into their evaluation code. Like, I was stepping through the code. Like, why do you get higher performance numbers out of this? And yeah, it turns out they made a mistake in their evaluation code. A very human mistake. They mixed their train and validation sets. It's an easy mistake to make, a mistake I would also make. It's an honest mistake they made, but they made it anyway. And sadly, when I fixed the mistake, I was sort of first still hoping, okay, I will fix the mistake. Hopefully the algorithm will not pick a sensible parameter and everything will be fine. It was not fine. The parameter stayed at 0. The reason they found that their method wasn't improving was because they had a bug in their code. So this was a very sad case. It can happen. So in this case, I actually had no choice but to reject this version of the paper. I would say, I think Jetse would also agree with me. This is like a failed experiment. This is your fMRI machine blowing up. Yeah, if you have a bug in your code, this is failed. It doesn't mean this result doesn't, or your study should never be published, but it should be a different paper, right? The paper should not be, we have a great new thing. So I had to reject this one. So that can happen. No one would ever have found this if they have not shared their code. And I was not a crazy person who actually goes through your code and actually tries to run it. It can happen. At this point in the story, we're in spring 2021, and the COVID restrictions were getting lessened a little bit, up to the point that we can finally have a sort of an outing with the team, with the software engineering team. We went, as Finns do, we went up to the forest and built a fire and had a barbecue together. And this is the first time we ever saw each other in person. This was not the only reason I was a bit nervous. On that day would also be the day that the Academy of Finland would post their decisions regarding grants. And when I applied to our RZ position, I also found that was not the only application I sent that month. The other application was for a rather large research grant for the Academy. So at some point I was sitting there with everybody having a good time, checking my phone every 5 minutes, until the email came, and yes, the Academy was happy to inform me they would award me this 5-year research grant. I remember just sitting there in disbelief, like holding my phone, staring into the fire, thinking, yeah, I've got a decision to make. On the other, I have an opportunity to like go back into research. 5 years. I can even. This grant even includes a PhD student. I can hire PhD students under me. I can start my own research group. I could be a PI, but it's a temporary contract. I have to give up my permanent position. I have to go back onto the hamster wheel. Do I want to do that? At some point, I made up my mind. Yes, I would go back. But I made a promise to myself. I said, okay, these 5 years, they are mine. I'm not going to let the publish or perish system take them away from me. I'm not going to let the hamster wheel take them away from me. I will only do things that I regard as meaningful, actually advancing science, or things I just enjoy doing. But I will refuse to do things that I think are pointless and I would only do just to pad my CV. If that means that at the end of these 5 years, my career in research is over again, that's fine. And I really try to stick by that. It's not always easy. But one of these things is that I continue to review papers and I continue to ask you for your data, for some data, and I ask you for your code. Because up to that point, every single time I asked, the authors complied. So in my mind, I think what's happening, if a reviewer asks, this is great leverage for a professor to go to their student and like force their student who is maybe like ashamed, like my code is a mess. Yes, all of our code is a mess. I cannot share this. Yeah, well, the reviewer asked, so you got to do it. On the other hand, it's also great for the student. So if you have a professor who does not allow you to share your code, it helps to have the request from a reviewer in hand. So if you want this paper published, and that's what the professor cares about, of course, you have to allow me to share the code. I think this makes a huge impact. And I think many, if not all here in this room, are either reviewers now or will be reviewers in the future. So I call upon all of you, do this. Use your power as a reviewer. You have a lot of leverage. It doesn't have, for in my case, it was always like looking at the code because I'm a software engineer and that's what I enjoy doing. It may be your own thing, but think about this. So how can you like leverage your power as a reviewer to promote open science? You have a lot of power there.